Hello and welcome to another session of Excel Programming for Clinicians with me, Dolodson Callow. In this session, we will look at some basic mathematics and I will show you how these are done in Excel VBA programming. We will cover addition and subtraction, multiplication and division, and powers and roots. And finally, we will take a look at brackets and remind ourselves of the rules around use of brackets in simple mathematics. Let's start with addition. To demonstrate addition, we are going to calculate mean arterial pressure. Let's declare a variable to hold that. Now to calculate mean arterial pressure, we need 1/3 systolic pressure. Let's declare a variable to hold that. And we need 2/3 diastolic pressure. Let's declare a variable to hold that. So let's say our 1/3 systolic pressure is equal to 40. Let's write that out to Excel. And let's say our 2/3 diastolic pressure is equal to 60. Let's write that out to Excel as well. And we calculate mean arterial pressure as equal to 1/3 systolic pressure plus 2/3 diastolic pressure. Let's write the result out to Excel. Let's run the code and see the result. And as you can see, we get 100 as expected. Next, let's take a look at subtraction. To demonstrate subtraction, let's calculate pulse pressure. So let's declare a variable to hold pulse pressure. Let's declare a variable for diastolic pressure. And another one for systolic pressure. Let's say systolic pressure is equal to 120. We can write that out to Excel. Let's say diastolic pressure is equal to 90. Let's write that out to Excel as well. Then we calculate pulse pressure as equal to systolic pressure minus diastolic pressure. Let's write the result out to Excel. Let's run the code and see what we get. As expected, we get 30. Next, let's take a look at multiplication. To demonstrate multiplication, let's calculate target heart rate. So let's declare a variable to hold lower target and another to hold upper target. Finally, let's declare a variable to hold maximum heart rate. Let's say our lower target is 0.77. And our upper target 0.93. And assume our maximum heart rate is 185. And to calculate our target heart rate, we multiply the maximum heart rate by either the lower target or the upper target. So to calculate the target heart rate for the lower heart rate, I multiply maximum heart rate by lower target. Notice that I'm using the asterisk symbol as my multiplication symbol and not X. Let's run this code and see what we get. So my lower target heart rate is 142.45. To calculate the upper rate, let's copy this code, comment it out, paste it below, and change to the upper target. Let's run this code and see what we get. And my upper target is 172. Next, let's take a look at division. To demonstrate division, let's calculate drug dose. So let's declare a variable to hold our dose. To calculate dose, we need a prescription, and we need to know what concentration our medication arrives in. So let's assume we have a prescription of 220 milligrams. Let's write that to Excel. And let's assume the medication arrived in vials that are 50 milligrams per mil. Let's write that out to Excel. And now we're ready to calculate drug dose. So drug dose is equal to prescription divided by the concentration in the vial. Notice that I'm using / for division. Let's write the output to Excel. Let's run the code and see what we get. And as you can see, we get 4.4. Now, what would happen if instead of using // we had used \\? Let's copy this code, comment it out, and paste it below. And change our / to a \\. Let's run the code and see what we get. As you can see, we now get 4. \ gives you the modulus of the calculation and is not to be used for division. For division, use /. Next, let's take a look at powers. To demonstrate powers, let's calculate the area of a circle. Let's declare a variable for pi, and let's declare a variable for radius. And finally, let's declare a variable to hold the area. Let's set pi to 3.1416. Let's write that out to Excel. Next, let's set the radius and write that out to Excel. So area, as you know, is pi multiplied by r squared, radius, raised to the power 2. Notice my notation for raising to the power 2. Let's write the result out to Excel. Let's run the code and see what we get. And as you can see, we get an area of 28.2744. Let's do one more power calculation. Let's calculate the volume of a cube. For that, we need to know the side. And we need to know the volume. We need a variable to hold the volume. I'll comment out this code. And this time we'll calculate the volume of a cube. So let's say the side was equal to 5. We can write that out to Excel. And we can calculate the volume as equal to the side raised to the power 3. And we can write that output out to Excel. Let's run the code and see what we get. As you can see, with a side of 5, the volume is equal to 125. Next, let's take a look at root calculations. To demonstrate square root calculations, let's calculate the side of a square given the area. So let's say we have a variable for area and another variable for side. Let's assume the area was 16. Let's write that out to Excel. We calculate the side by using a built-in Excel function called square root. If you type in SQR and brackets open, you can put any number in and calculate the square root of that number. In our case, we're going to put in a variable which holds the value 16. Then we can write out our output to Excel. Let's run that code and look at what we get. As you can see, with an area of 14, a side will be equal to 4. Next, let's take a look at brackets. Now, brackets work in exactly the way you would expect in basic mathematics. First, there'll be brackets open, and then there'll be any division, followed by multiplication, followed by addition, and followed by subtraction, in that order. To demonstrate this, let's do some simple calculations. Let's declare a variable for age. And let's declare a variable to hold the results of our calculation. Let's say the age was equal to 50. Let's write that out to Excel. What do you expect the result would be if we say bracket open 25 plus age, bracket close, multiplied by 2? Let's write that output to Excel. Let's run the code and see what the output is. And if you predicted that the 25 would first be added to the 50, and then the result, 75, would then be multiplied by 2, you are obviously correct. Let's say we did it slightly differently. Let's comment out this code. And this time, put the brackets around age and multiplication by 2. What do you expect this time? Let's run the code and see. And of course, we get 125 because age will first be multiplied by 2, and the result, 100, would be added to 25. So, as we say, brackets work in exactly the way you'd expect from basic mathematics. Next, let's take a look at rounding. To demonstrate rounding, let's borrow our calculations from dose calculation earlier. And this time, write the results to row 23. I'll change the values of the prescription and the vial. So we have a prescription of 250. We have a vial that's a concentration of 30 milligrams per mil, and we want to calculate the drug dose. Let's run the code without rounding and see what we get. And as you can see, we get 8.33 recurring. Now let's see what rounding does for us. Let's copy this code, put it below, and this time, instead of outputting just the dose as it comes, let's round up to. If you use the built-in Excel formula round and you open brackets, it asks you for a number, in which case we'll pass in our dose, which holds the result of our calculation of prescription divided by vial. We'll put in a comma. The next parameter it's asking for is the number of digits after the decimal. In this case, I just want to display 2 digits. Let's run that code again and see what we get this time. And as you can see, this time it's rounded up to just 2 digits after the decimal place. So just before we finish our basic review of mathematics in Excel VBA programming, let's take a look at how we can use some of these calculations together. So to start with, we want to calculate BMI. BMI in kilograms per meter squared, as you know, would be equal to weight in kilograms divided by height in meters raised to the power 2. So this is what we want to demonstrate. Let's declare a variable for weight, another for height, and another for BMI. Assume weight is equal to 85. Let's write that out to Excel. Now let's set height to 1.69. So we calculate BMI as being equal to weight divided by height raised to the power 2. And we can output that to Excel. Let's run the code and see what we get. So, with a weight of 85, a height of 1.69, we get a BMI of 29.76. Let's add our rounding function and round to 2 decimal places. Let's run that again and see what we get. And we get 29.76. Let's do one more calculation. Let's calculate body surface area. Now, body surface area is calculated in meters squared and is equal to height in centimeters multiplied by weight in kilograms divided by 3600 and all raised to the power half. So let's copy this code, comment out our BMI calculation, and use our height and weight to calculate body surface area. We'll leave the weight as 85 in kilograms, and we'll change the height to 169 in centimeters. And then we'll say our body surface area is equal to, bracket open, height multiplied by weight divided by 3600 and all raised to the power 1 divided by 2, which is half. And that should be our formula for body surface area. Let's write the output out to Excel. Okay, let's run this code and see what we get. And we get nearly 2 meters. In fact, let's round this to 4 decimal places. Let's run it again. And our body surface area will be 1.9976. Okay, so that's been a very quick demonstration of how to do basic mathematical calculations in Excel VBA. I hope you enjoyed that, and I will see you in the next video.